okay? And just also remember the main idea of having these is so that you can find missing side lengths. That was like the main thing. So you have missing side. You could also use it to find angle measures. That's fine. But the main purpose would be really finding something that's missing in terms of a side length. When you write out all of these, you got to make sure that your answers are as improper fractions. Okay? So you don't want decimal numbers here, you want fractions for answers. So if you have like a square root or something, make sure that's included. All right, don't convert anything to decimals. So the idea would just be a matter of going, well, I got a right triangle. Pretty much everyone should know if I've got two sides to it, I can find the third side by doing Pythagorean theorem, which is what they'd want you to do. In terms of this triangle, since my right angle's up here, this would be your hypotenuse. This would be the side that's opposite that angle, and this would be the side that's touching it, so it's the adjacent. So for the Pythagorean theorem here, that would be like 41 squared plus a squared. And if you solve that out, what do you get? Someone do it for me. Square root of 41 squared minus 40 squared. Whatever the heck that is. I don't remember what it is actually. 9. This one's nice. Okay. Yeah. So now, again, a problem like this, and usually, if you do geometry or anything else, a problem like this will get overthought if this was on a test. It's not asking you to do anything else than write the fractions out. So it would be practice in matching things up, such as if I go in there, sine was opposite over hypotenuse. So all you need right here is the 40 over 41. Okay? Usually in another class, if this was on a test, someone would do the work to try and find this angle and then go from there and try and get all the functions, but they get decimals, so it'd be wrong, and they just do too much work and they don't need to do it. What you should be writing, again, is just improper fractions. So this would be 9 over 41, right, because that's adjacent over hypotenuse. Tangent would be your opposite over adjacent, which is 9. Secant, reciprocal of cosine. Cosecant would be the reciprocal of sine. And cotangent is flip of tangent. And that'd be it. There's nothing else to do. Like, that's literally all the problem's asking, which is saying find the trig ratios, and that's exactly what happened there. So it's not like, it didn't technically say find the side. I needed that to get the answer done. But I don't have to find this angle or this one down here. I would have people label the triangle with opposite, adjacent, and hypotenuse, just, so that they realize how to pick it. Usually if you get to this point, most people can see which function needs to be used ahead of time, but just in case you ever have issues with that, if this is the angle they're given to you, this side is the one that's in contact with it, so that's the adjacent, that's opposite, that's hypotenuse. And then the trig function you always pick is the ratio that is involving the two sides that are labeled. Like, nothing's on the adjacent, so I can't use a trig ratio that has adjacent in it. So that means like tangent's gone and cosine's gone, and all the reciprocals of that. So since I only have the hypotenuse given to me and I'm finding the opposite, the only one that makes sense here that involves both of those would be sine, okay? Not cosecant, because cosecant's not on your calculator, so it wouldn't make any sense to set something up with that. And if you remember when you set these up, these are always like sine of theta, and in this case, theta always stands for angle, so my theta would be 30. So you're replacing that with actual measure. And then on the other side, you're doing the opposite over the hypotenuse. Or if you remember, like 30, 60, 90s, you can do this quick also. You guys should, you could do this one without the calculator because 30 degrees is on the unit circle. So I know I could go to unit circle, figure out what sine 30 is, which is 1/2. So I can do 1/2 equals that. So if I multiply the 25 over there, I'll get 12.54. Okay. If you want to do these without unit circle stuff, this would just be multiplied over. So if you wrote this in terms of a trig function, like if it wasn't 30 degrees, you might see it written this way, and then they give you a decimal after it. So guys, with the solving ones, solve means find everything. Anything that's not up there labeled with the number, you need to put a number on it. Angles and sides. For the ones right now that you're going to be dealing with, you don't have to do the inverse trig functions or arc sines and arc cosines and stuff to find the other angle, because of the idea that in these right triangles, these two angles should always add up to 90 degrees. Or if it was like a radian measure, right, 90 degrees on the unit circle would correspond to pi over 2. So if I had like a radian measure up here, which would be like pi over something, I would have to add these up to pi over 2. But if it's degrees, just remember these two add to 90. So this angle would be probably the first thing I would do by just doing 90 minus that, which would be 38. And the whole reason I would do that is because if I know what both the angles are, that means that you can use either one of those to find the side lengths. So if I want to use 52, I could, or if I want to use 38, I could. So that just kind of gives you more options in terms of finding the sides. Just for the sake of, since they have it here, I'll use this angle. And I'm going to do this still the same way I did the last one. So this was my angle. This side right here is coming in contact with it. So that's adjacent, because it's not the longest one. The side that comes in contact with it, that is the longest side, would be your hypotenuse. And this would be the opposite one. And again, the whole point when I do this, like in geometry, or when you first see this stuff, the whole point of doing that is so that this is going to determine if you use sine, cosine, or tangent to solve it. Should I find the opposite side or the hypotenuse first? It doesn't matter, you pick. Opposite's the first one. Okay, so if I'm finding this, then I'll just put a X on there just for the sake of setting up the problem. I've already determined I'm using this for my theta. I've determined I need the opposite in my ratio because that's what I've labeled as I'm trying to find. And the number given to me is adjacent. So again, the way you pick this is you pick the trig ratio that has adjacent and opposite in it, which would be tangent. So again, it's like tangent theta is opposite over adjacent, so it's just a matter of filling in the correct numbers there. Okay, so I've determined what my angle is 52. All right, so tan 52, and then you just fill in opposite was x, adjacent was 35. So again, since my variable is on top, that means I'm multiplying the 35 over. It's just solving a proportion. So this is x divided by 35, so I multiply 35 times the tangent of 52. And that should get you some kind of decimal number. What? 7. Okay. With solving now, like if you prefer to do Pythagorean theorem to get the third side now, that's fine. If you prefer doing the trig ratios, it's fine too. Trig ratios usually take a little bit less time, but if you are more comfortable at this moment doing Pythagorean theorem, you should get we'll put a y there. You should get the same number as if I were to set this up with like sine or cosine. Okay? So if I was doing it, I would do a trig ratio just because I think they're faster. And if I was setting this up to find the hypotenuse, I would have set it up with cosine because I'm finding the hypotenuse and I started with the adjacent. 35 y there. Okay, but again, Pythagorean theorem's fine. Okay, they both can be utilized. So either way, whether or not you solve it that way, we do like 35 divided by the cosine of 52. You divide them because your variable's in the bottom. So if you did like cross multiplying, it would end up in that manner. Or if you did with Pythagorean theorem here, you should get some number that's larger than 44.7. It should be in the maybe 50 range. 56.8. Solve it, so that means find everything. So since this is in radians here, that means these two are still adding up to 90. But in terms of radian, right, your unit circle, like this is your 90-degree mark, and that was a measure of pi over 2. So it means that these two have to add up to pi over 2. So this angle down here would be pi over 2 minus 3 pi over 8. So, yeah, so this would be pi over 8. What I have for x and y, this would be, I'll stay with the number they gave me, the 3 pi over 8. It doesn't really matter. This right here would be the hypotenuse, right? Longest side. This side that I put the x on would be the adjacent because that's the one touching the angle I'm looking at, and this one would be opposite. Hey, just keep in mind if you're flip-flopping angles, guys, that's going to change what your measurements are there. You need take it. Okay. If I found x first, guys, this would be adjacent, and hypotenuse is what's giving me, so I'm doing cosine. When you guys do this in the calculator, either make this number a decimal first before you do cosine, or make sure you group the entire thing in parentheses. Okay? Just so your calculators are stupid. If you don't group them the right way, it doesn't know what the heck you're asking it to do. So just make... Yeah, adjacent over hypotenuse. So I'm finding what I said was x. Right, and then let me set up the other one. Okay. And then say like if I was doing this, I would do both those. Especially guys, I would probably stick strictly to trig ratios. Especially if I'm setting up a ratio on this side, my variable ends up in top. Because if it's on the top, I just need to multiply that number over. Which usually for people, that's easy to grasp and not a major issue. Okay? Multiplication is usually not a big deal. So again, when you're doing this, if you're doing this stuff in radians, because these are all radian measured, make this a decimal first before you do cosine or sine. Or make sure you fully have it grouped in parentheses. Those are the two numbers you should get. This side here should be 163. That should be 393.